thank you all for joining us today. Very honored to have you here. We're going to talk about some new work. My name's Alan Friedman. I'm a senior advisor and strategist at the Cybersecurity Infrastructure Security Agency. Many of you know me for SBOM, so this is some new work that you'll start to see isn't identical to SBOM, but it's going to rhyme a little bit as we get into it. And so we're going to be tackling, similar to supply chain, something that we all know is a thing that we need to worry about. But it's always been big and messy and intersectoral that we really haven't built something holistic around it. So this talk is trying to lay out a potential agenda of how we can collaborate and what the moving pieces are. First, our disclaimer. Well, that's unfortunate. Oh, there we go. Which is, right, you can't do this. And also, right, we are talking as some thoughts from CISA, but this is not meant to lock in government action, and no products or services are explicitly endorsed. So this is a picture that took last week from a medical device conference in New Orleans, where they had a funeral march, because it turns out you can just rent a second-line band in New Orleans. So they had a funeral march through the French Quarter, planning the end of life for Windows 10. We really confused a lot of tourists. But the other thing to note is in the medical device community, we are really lucky if things today are shipping with Windows 10, which again is no longer going to be supported a year from now. The vast majority of blinking boxes that keep people alive in hospitals is using much, much older operating systems than that. So let's think about, how old's your cell phone? How old's your VPN appliance, your car? The cell tower that your cell phone is talking to? The MRI machine that you kind of really need to work? The backbone switch, the aircraft carrier, right? We are surrounded by old tech, and that's okay, right? We shouldn't say only the newest and shiniest all the time. In fact, that's sort of a bad policy. But what we need to do is have a better understanding of our risk exposure. Now, how is that usually communicated? Well, unfortunately today, it's communicated terribly, right? Here's a random website that says, and the fine print on this just says, hey, by the way, these D-Link devices are end-of-lifed, right? A lot of text on a random web page intentionally left small here because you have to read to that line to figure out what's going on. Now, why am I mentioning a random home router? Well, some of you may have heard of Volt Typhoon, where home routers and small business routers were used in an attack that ultimately popped the island of Guam. Right? The entire island was pwned as part of a massive attempt not just to engage in espionage from a foreign actor, but to actually attack and put implants into American critical infrastructure. If you want to know more, I encourage you to look up Volt Typhoon. This is something that we at CISA have partnered very closely with agencies across the US government and intelligence agencies around the world to draw attention to. Some of you may have talked about Ivanti recently, right? It's on the network. It sits on the edge of your network so attackers can get direct access to it. Once we saw that this was being actively exploited, some people looked under the hood and said, oh yeah, there's 5-year-old libraries in here. There's 10-year-old libraries in here. There's 15, 22-year-old components in something that is a direct entry point into your organization. In the supply chain, right? Not the box itself, but the things inside the box that you may not have visibility into. Now, again, this may not be intrinsically bad, But almost all of us would raise an eyebrow if we knew about that before purchasing. I don't think we're allowed to have a supply chain talk without talking about XZ today, but it gets into the idea of understanding how old and who is touching a lot of what we're talking about. Open source, proprietary, there's a massive amount of outdated software. How much? Well, the Wall Street Journal came up with a number, or quoted a number, from an organization called CISQ. It said this is a $1.5 trillion problem. So one of the core takeaways here is that rip and replace is not on the table as a holistic solution. So we need to start with that knowledge, that this is going to be expensive, but we're also not going to be able to just say, well, write checks to solve it. This is a quote that I remember from my coding days. When I wrote this code, only God and I knew it was in the software. Now only God has it. Right? This is a common thing from the Cult of Dead Cow days. What I love about this that I hadn't seen before is there's a counter. So every luckless sod who opens up the code base to try to figure out what's going on is encouraged to add their soul into the count of how much time we wasted on this. Because again, old code isn't just a risk, it's immensely time consuming. So why are we thinking about this in the US government? Well, it's part of the United States National Cybersecurity Strategy, where we explicitly say we need to develop a process for identifying and mitigating the risks of unsupported software that's widely used or supports critical infrastructure. I think this is a fantastic part of a fantastic document. If you haven't seen the National Cybersecurity Strategy, still holds up and has been expanded just this week. Our friends at the Department of State announced our international cybersecurity strategy. And we didn't just write a strategy. The White House said, all right, how are we going to implement this strategy? And in the implementation plan, we explicitly said, well, this is one of those fun games of telephone inside the federal government. We said, all right, CISA is going to lead on this, and we're going to evaluate the requirements of a centralized way of addressing this. I'm not going to propose a centralized database. Software is too big for any solution to have centralization in 2024. But there are some things that we're going to do. And the other piece I want to also acknowledge about why this is important to us in the government is we are one of the biggest perpetrators of continuing to use legacy software. And some of that we're very aware of. There's a really cool team at Hill Air Force Base, the 307th Software Engineering Wing. And they're trying to use modern DevOps and DevSecOps practices to maintain the F-16, which first hit production in 1987. And I love it. Like, that is a super hard job. They're an amazing team committed to a very hard problem. But this is the world that we live in, where we can't just say it's old. We have to figure out what support looks like. So let's talk about software, right? Most software, or not most software, excuse me, a lot of the software that we worry about is proprietary. It's made by someone. Maybe they support it. Maybe they tell us when they stop supporting it. Our friends in Europe are trying to put some rules on in laws to say, what are we going to do to require at least notification of how long do you have to support things? But again, a lot of that outdated software is still in operation. Remember Volt Typhoon? A big part of the attack vector was using software that was no longer supported. So the vulnerability, it was there, it was known, but it wasn't even part of anyone's radar for anyone's support contract. And listen, CISA works with the private sector a lot. We understand that the assumption of supporting things comes at a cost. No software will be able to be supported forever, and that has to be built into our calculation. But it also gets a little confusing because even saying what support is gets very complicated. There's so many terms that are used by different industries, by different sectors, by different verticals, by different business models. So end of expansion says, all right, it was end of life, but we were still allowing you to buy more of the same stuff, and that's what we're going to stop. In some cases, a single company will use all of these terms, and they'll all be at a different date. This is pretty frustrating. And predicting, figure out where, yes, there we go. Predicting when end of life is going to happen is tricky. So put yourself in the mindset of someone who's producing a widget. You don't know if you're going to sell 1 unit or 1 million units. We can say you have to commit to supporting that 1 unit 4, 5 years, 10 years. That could be good policy. But we need to acknowledge what that is going to actually cost. We're seeing sector-specific regulations and policies. And I put this eye chart up here, not because I want everyone to read International Medical Device Regulators Forum documents, but to acknowledge the idea that there are a whole bunch of open-ended arrows as we think about our supply chain and our support. And the medical device community treats things different from the energy community, which treats things differently from the advanced manufacturing community, which is very different from the automotive community, which is very different from telecom, right? So we all have different models. And one of the things we always quibble about is who's going to pay? Who is going to actually provide this support? It requires work. It's boring. Some enterprises say, okay, once we have to worry about support, we're just going to offshore all of our support. It's cheaper, but it's not necessarily free. When people looked at what happened after Volt Typhoon, and they saw that there was a compromise in the core ISP networks on Guam, and they saw, hey, on one hand, this is a product which had a vulnerability, but on the other hand, the patch was available. Whose job is it to think this through? And there's been some really interesting discussions that have emerged from that between the manufacturers of networking equipment and large ISPs and carriers to say the solution is not just to point at each other and say it's your responsibility. It's to figure something out about how we're going to arrange this. And again, step one is visibility. We also need to be very clear that end of life is not a vulnerability by itself. There is a lot of software out there that is no longer supported, and the security assumptions that were made while it was under support are identical to the security assumptions today. So we can't treat this as the same thing as a vulnerability, but there are a lot of security considerations we can walk through. I think a lot of it is about risk awareness. I've talked about responsibility. Can we talk about patches and updates in certain cases? Right, I think that's going to be a big part of it. And I'm going to talk about open source in just a second. Should we think about established product security models? So ISO 30111 is a great example as a formal international standard for how an organization should handle new security information coming in about the security of their products. And what a lot of organizations want, especially on the mature side, is having some risk smoothing, right? Not to abandon everything, but to say, let's move forward. So all that's on the proprietary side, but let's now start looking up our supply chain and saying, oh, wait. Most of my supply chain these days is not proprietary. There's no contract. There's no one who is single-handedly responsible for this. Open source is an incredibly diverse space, and it covers very mature projects where there are hundreds of people sitting in standing bodies with lots of roles, to a hobbyist who just does things on the weekend, and it turns out a lot of people wanted to do what she did, what she built. Is maintenance something that we can expect for that? Well, in the end, the answer is it depends. In our OWASP top security risks, unmaintained software and out-of-date software are risks 4 and 5. And again, not to endorse the methodology of this study, but if you start looking at any major code base, you're going to see that people are using outdated software in their supply chain. Often very outdated software. We don't have visibility about that today. So I love this component that half of the software has components where there's been no update in 2 years. Another recent study by some folks in ChainGuard said, hey, if we're looking at containerized applications, and we sort of see what the age is, so this is the new stuff, as we go back in time to the older stuff, we get more and more vulnerabilities, not just from the application itself, but for everything else in that container. So will you regret using older images? Well, I'd argue maybe not today, maybe not tomorrow, but someday and for the rest of your life, you're going to regret having this sort of massively out-of-date software supply chain. What are some of the other concerns? Instability. There's a reason why software requires constant maintenance. Because we're always stress testing it. We're always using it in slightly new ways, and we need constant fixes. That's not a security issue. Technical debt. Someone's going to have to pay the piper if we keep using this. We need to track it as we can move forward to figure out, okay, am I still comfortable using this thing, or are the long-term costs, the debt that I'm accruing for it, just overwhelming me? And there are lots of legal and regulatory obligations. Depending on how you read PCI, there's a requirement that says you need to have the ability to patch everything. Well, if it's not maintained, I would argue you are out of compliance with PCI. It's true for a lot of other regulations out there, including the national security community. In the open source world, we face a real problem, which is this thing even supported at all? How do we actually know? Sometimes it's super easy. Right? So here's Spring Boot. Some of you use it. It sort of says this is the stuff that's supported. And the cool thing about open source is they say the open source community isn't going to maintain this. But guess what? We've got some experts in this. And so we'll support it, but you got to pay it for it. So we're moving from an open source model to a proprietary model. That's something that I think is very important to remember, is something can be end-of-lifed and then magically come back to life because people have said, oh, enough people want maintenance on this that we can manage it. So can you look at a project and figure out, is this maintained? Yes and no, right? There are signals, number of maintainers, stars and forks is always nice. Is there any recent activity, right? Have people been opening issues? People doing pull requests? Is there any security communication capability? That's nice. But this is how many results there are on GitHub for is even. Do I need to maintain a function that tells me whether a number is even? I don't think any of these other metrics would apply because this is just stable code. So you can have small enough increments of code in your world that we can't clearly figure out what it looks like. So as we think about end of life moving forward, we need to figure out a solution that works for standard software that sits on our network. We need to think about critical infrastructure. Right? That's one of our priorities at CISA, is keeping the lights on, the water running, making sure everything works the way it's supposed to. And we also need to explicitly think about the supply chain of all of that stuff, because that's also an increasingly common attack vector. So what's the solution going to look like? The vision I'm going to sketch out is data to support policy. And so the first step is to say, let's work very hard to work on these concepts separately. Let's not tightly bind any solutions. Because that way, we can help focus on the data layer at the technical approach and then figure out how we can map this to both organizational policy and, of course, public policy. I also want to be clear about what we're not trying to do. And again, we're not trying to ban outdated software. Keep coming back to this because that simply is not a feasible solution. What are some other things that we shouldn't be trying to solve as part of this effort? Software versioning, hard, messy problem. Boy, it would be wonderful if everyone used semantic versioning. People have tried to tell everyone to use semantic versioning for quite some time, and it hasn't worked. And again, this also applies to legacy systems, open source. Telling people to do a certain data model isn't a path to success. We're not trying to solve the business case for maintenance or lack thereof. We need to acknowledge it, we need to discuss it, but we shouldn't try to directly address it. And one of the more important things that I always like to emphasize is we're not trying to tell open source maintainers what to do. We want to help empower. We want to create infrastructure that we can bring to that world, especially as users of open source, but we aren't dictating it. So what are we trying to do? It's purpose-driven transparency, saying we need visibility, and from that visibility, we can map to action. So data to intelligence to action. And some of you are saying, gosh, Alan, this is sounding a little familiar based on what you've been talking about for the last 5 years. And look at who's giving this talk. So y'all want to say it with me? What does this seem like? This seems a lot like SBOM. Okay. Not quite. There are some very important distinctions that we need to go through. One of them is definitions. What are we trying to actually solve? And so I want to flip this around and say, rather than define what end of life is, let's talk about security support. So what's that definition? This is the straw man. And we would love your support. I've been starting to map this to how this is handled in other environments, but this is the basics. So let's walk through it. Reasonable expectation. Is it a guarantee? No. But it's the sort of thing that you can then go to say, yeah, this seems reasonable. Of a predictable, effective response to a new security risk. So, new security risks happen all the time. We talk about vulnerabilities, but we don't want to be explicitly locked into vulnerabilities. But in the short run, you can read this as a new vulnerability. We need a response that is predictable and effective. Does the response need to be a patch? Not necessarily. But it needs to be effective for the context, and it needs to be predictable, which is to say, I have some idea what that response is going to look like. So I think this gives us enough flexibility, and it highlights security. One common challenge is there's an interplay between product support and security support. And as much as possible, I think it is going to be a very good idea to try to keep them separate. There are some really interesting complications there, but we want to start off with that model. All right, so that's our definition of what security support is. But we need to talk about the what, the when, and the who. So the what is software. Now, some of you may know that naming software is an embarrassingly hard problem. It's a famous quote, there are only two hard things in all of computer science: cache and validation, and naming things, and off by one errors. Last fall, CISA wrote a paper, the white paper, that says, hey, we've got to stop just talking about it and do something about it. And so what did we do? We wrote a paper that talked about it. We tried to sort of lay out, when we started this project, of we could either do A or B. And it turns out it really isn't that simple, because there are many different approaches to identifiers. There are extrinsic identifiers. I name this piece of software Steve. And then there are intrinsic identifiers. Here is a hash. And there are differences of why each of them don't meet the needs of everything. So where we're probably going to go in this, and we're working on this right now, is an ecosystem where we support multiple identifiers in our vulnerability world and beyond. And definitely for end of life. So being able to say, this product ID for an IoT project, which is the same thing as the hash of the firmware image, which is the same thing as the package URL of the open source version of this, all point to the same one. So we need to be clear about what. We need to be clear about when. And this gets messy, because again, there isn't going to be a single one-size-fits-all. Our friends in Europe have already built some policy, Cyber Resilience Act, about a support period. That's defined as the time the product is expected to be in use, and the manufacturer provides support updates. Under CRA, it's at least 5 years. I don't think at a top level we need to define that period. We just need to be able to talk about what a time window refers to and be explicit about it. Let's not lock in the policy. Let's lock in the ability to describe the world and then layer policy on top of that. The who gets a little fun, because when we're just thinking about proprietary software, well, then it's pretty obvious, right? It's the person that I've written the check to. But when we think about supply chain, we think about open source, we need to be very clear of what we're doing, and we want to enable a broader set of people to make assertions. Now, we've seen this in areas like vulnerabilities. Has anyone here heard of VEX, the Vulnerability Exploitability Exchange? I won't get into it, but it's the ability for someone to say, this product is or is not affected by a vulnerability. There's some great work happening in Oasis. There's some great work happening in the Linux Foundation to support this idea of VEX. If you want to learn more, cisa.gov/SBOM. But the unique thing that kind of terrified big software vendors is a world where anyone can make that assertion, and we have to push the intelligence of, do I trust that assertion, upstream? Because lots of people can say, I will support this open source software. You want to allow a small community, a random person on the internet, a startup someplace to say, I will support this. But you may not want to trust it. And so we need to have enough information to capture this. So when we're thinking about this data, the other thing to remember is that this is not static data. This is going to evolve over time. And that's important because it's similar to vulnerability data rather than, say, I don't know, SBOM data, where when we're talking about a piece of software as it exists, that's static. But the status of, is this vulnerable, is going to change over time. And the status of, is this supported, it'd be lovely if we knew the exact truth at time t0, but we may not. And we need to build that into our data schema and to how we use that data. So I've been talking a lot about a data schema, and it's not just hypothetical. So what do we want for this data? It needs to be automation friendly, right? It's 2024. If you are doing anything in security that isn't aimed at automation, you're doing it wrong. Right? So it's got to be machine readable. It's got to be useful across sectors and take concepts. Manage the fact that different sectors and communities and countries already have slightly different policies. And we want to integrate it into our existing risk tools. So the good news is, as I mentioned, there's some work happening. It's under Oasis. It's quite new. So this is the chance to get involved if you want to. Oasis is an international standards organization. It's a formal SDO. You can go to OpenEOX. You can go visit the GitHub website. One of my colleagues, dare I say proteges at CISA, is one of the co-chairs of this, along with Omar Santos, that many of you know. He's a long-term leader in the vulnerability community. So this is just beginning, right? 6 contributors. There's really cool stuff here, but the working groups are just started, and anyone can join. So openeox.org, I think, is going to be our path forward from a data layer. But again, that's not, the data layer is part of it, but it's not all of it. Where do we find this data? As I mentioned, centralized databases are hard. Anyone who's played with CPE, Common Platform Enumeration, learns that at a certain point, it's very, very hard to scale. There's a really cool project called endoflife.date. It's run by one guy in India. He's awesome. I met him at his first trip out of India. He came to FOSDEM, the European open source conference. This is a cool idea. But it only has, as of screenshot, 302 projects. That's a lot. Chances are the big ones that you use are in here, but that's not everything. And so what's the solution going to look like? Again, we're bumping into some pretty common security problems from infrastructure that there isn't an easy solution for. Usually the buzzword that we're going to aim at is federation. Rely for proprietary software on the vendors to maintain this data in a machine-readable way so that they don't have to go out and push it, and so that we don't have to worry about consuming random websites or random PDFs or random announcements where the information isn't obviously there. So we have some definitions. We have a way of conveying the data. We're going to start thinking about where to put the data. What do we do with it? So my buddy Dan Lawrence, founder of ChainGuard, paraphrased General Mad Dog Mattis: be polite, be professional, but have a plan to update every piece of software you use. That's sort of the core of where we all need to head, which is not to drive things off your network, but to focus on saying, what are we saying? I have a plan, and I can handle things based on what we have for EOL. So patches aren't the be-all and end-all. Again, for EOL, love software updates. They're important, but there are other things that we can do to protect ourselves from novel security risks for EOL software. First, obviously, explicitly put it into your risk model. Work with your IDS, your threat intel. Say, hey, I need to know the second that anyone is doing an exploit for this thing that I don't have the ability to easily and updated patch. Doing rapid exploit analysis so that we can map this back to what's actually going on. Network-based protections are always nice, right? Software world doesn't have security in a lock. Put things in special networks, lock them down. Heck, one thing that I've heard a couple of organizations have for software that they absolutely need to run is they've built custom kill switches. They said, we know that we can yank this thing if we have to. And we've got our threat intel, and we work with all of our fancy government agencies, including CISA, to find out the second we need to worry, and then we pull it off the network. So we can respond quickly if we have to, and when we have to. A few other considerations. Again, we shouldn't treat this as vulnerability data, but we should learn and model our approach on how we think about vulnerability data. We've got 25 years of organizations taking data and being systematic about it. Identifiers are important. Data sets are important. Prioritization is important, right? No one just has vulnerability management, they have vulnerability management today. So we need to sort of build on those lessons and start thinking about them. We need to share data, but we also need to say, if this is public, what are the risks of someone trying to poison our data set? And how do we make sure that we're not trusting everything? There's room for the private sector, startups to come in and say, yeah, we'll do all the analysis for you to figure out whether this is trustworthy. There are private threat feeds. Again, none of this is new in security, right? We've done this for everything from phishing URLs to IOCs. And then the last piece I'm going to focus on is what evolutionary biologists call the half-a-wing problem, which is if we start building this but say that there's no value until we've solved the problem for everyone, we're never going to succeed. So we should start making a case for why there's value for early adopters, both on the supply side and on the automated consumption side. And some of that's going to happen from the private sector. There are a couple of great companies today that are collecting this data and pulling it in from different places and making it easily digestible to SOC teams, to acquisition teams. Third-party risk management orgs are starting to explicitly include this. There are a couple of companies that actually use SBOMs to figure out metrics of technical debt, right? Are you about to be one of only 5 customers of something that's built on a 7-year-old framework that is going to have to be refactored at a massive cost? And I think some of it is going to come from your friends in government. First, by talking about it, like now. Second, by starting to use it internally and starting to put it in government contracts. And guess what? Government gonna government. So this is a risk that is already built into a number of regulations. This is something that is in almost finalized Cyber Resilience Act in Brussels. This is something that is going to happen. So our next steps on this is, from CISA's perspective, to start doing more direct outreach to different sectors and different communities, making sure that our assumptions are not wildly off base. In just a moment, I will encourage you to stand at that mic and throw things at me. Work on EOL, OpenEOX, the standards model, and start thinking about how we can integrate this into our world. If nothing else, start asking for this from your suppliers. All right, so we need our RSA. Did I just waste 50 minutes listening to Alan try to be funny and not really succeed? And so what do you need to do today? One is just start asking questions. In your organization, do you have any policies about EOL, EOS? Are any of the tools that you have on your network things that can incorporate EOL risk, give you any information? You know how you have about 300 single panes of glass? Do any of those have this? And if you're on the product side, start looking not just at your products, but your supply chain. Visibility to the supply chain is absolutely key. CISA.gov/SBOM. But how do we start to think about your suppliers and your suppliers' suppliers in the open source world? And by the time we roll around to next year's RSA, start booking your hotel rooms now, April 28th, 2025. Let's talk. We'll have made some progress on data. There are a couple of folks that are already working on some really interesting open source tools. I can't wait to publicize them and work with them. And again, we need to collaborate a little more. And that means, hey, in the healthcare space, we've got hospitals with hospital IT. We've got medical device manufacturers. Those are two very different sectors, but they fulfill similar metrics, similar models, similar benefits, and they run through the same organizations. So hopefully we will have organization-specific places to keep this data. OpenEOX may not be a final standard, but it's going to be pretty mature by then. We're going to have suppliers start tracking this information for us and making sure that we can have this as part of our contract language, as part of our long-term support models. And of course, we're going to be taking this data and not putting it in our SBOMs, but linking it to our SBOMs. All right, that's the basics of how we're going to take this big, messy issue that everyone in the room has heard of before and start doing something a little more concrete, a little more focused, but still flexible enough to meet our different needs. So, very, very happy to be told what's already being solved and that this isn't a real issue, or that there are a lot better ways that we can do this. If you would like to talk, if you would like to share ideas, if you want a copy of these slides, please reach out to me. That's how to get in touch with us. Happy to talk about all of the great other work that we're doing at CISA, cisa.gov/SBOM, and move on from there. So thank you so much for your time today. This is kind of a fun time for me to look out and say, 3 years from now, hopefully we will have gotten our hands not to solve this problem, but to make this a boring problem. To have our hands around it in a way that this just fits into the rest of our tools and the rest of our thinking about risk. So that's really what we're trying to do in cybersecurity, is turn exciting problems into boring problems. And I think we actually have a chance to do that fairly quickly with EOL-EOS. And I hope you'll work with us. Thank you. If you have questions, there's a mic.
I have a question.
Please.
Do you have any recommendation about how to support or maybe ensure that legacy systems that are installed on end-of-life operating systems, for example, Windows 2003, for example?
Sure.
What are the best actions to do to protect them?
There's no magical cure for legacy technology. That's one of those things. Every sector has tried to address it in their own ways. The models are, there was a slide I had about non-software-based mitigations, but it's going to depend on where you're using those systems and how you're using them. The most obvious and immediate one is, dear God, keep that thing well away from the internet. But there are other things that you can do, including threat intelligence, right? Knowing exactly what of your legacy system is on that. So, right, if you're using a legacy version of the kernel, you don't have the whole kernel. You've got only small parts. If you have a medical device, right, embedded compilers are violent. They rip a lot out. So you can start to figure out what code is actually there. And then, of course, the host of cybersecurity solutions that people with bright lights on the expo pole will help you with, of broader-based network defense. I wish there was an easy solution. This is one of those areas where, yeah, we've just been doing it for a while.
Thank you.
One question. You can even offer a cormorant if you prefer, a fishing bird. Go ahead.
Curious, when we have this data about end-of-life systems in our networks and our business, is it the expectation then that we take that to business to make the decision on risk? Are we providing that as an input to their decision-making process? Do we give it back to them to say, here is your poison baby, you deal with it sort of thing? Or does it come to our side?
I think it very much depends on your organization and what you have, right? There are going to be many, many cases where just, I am never, right? This blinking box is keeping grandma alive, and it's going to keep keeping grandma alive. Versus, yeah, this is my cloud native thing just is based on old stuff, and so this can help me prioritize this. So again, let's use the analogies we have from VulnWorld, where I can't fix every vuln in AppSec, but at least we can say, this is our hit list. And that, I think, will be helpful. Thanks. You get the last word, and then I'm going to get thrown off the stage.
Right. I remember from like 10 years ago, RiserFS was created by a guy and he got arrested for some crime that he committed. So that file system was very promising, but got stopped maintained. So why are we not tracking individual developers in some anonymous way so that we know when the softwares are not properly maintained, hence maybe accelerating the end of life, end of support for so many cases. Some of them are corner cases, some of them are legit cases.
Super quick answer. One, open source is massive. It is in an infinite sea of software. So tracking specific things is quite difficult. Second, lots of people in the open source world don't like it when the US government watches them. So like, we have to be very careful. There are tons of services out there that are explicitly focused on open source risk. Some of them are on the shop floor today. All right, that's my red stop button. Thank you again. I'll be outside if anyone wants to chat. I've got business cards. I've got S-Bump stickers. Have a great day.